Completed the voltage amplifiers, different types of voltage amplifiers, their working principles, applications. So, and now we have to go for a power amplifiers and tuned amplifiers. So, power amplifier, we already discussed that it is the large signal amplifiers. It is a large signal amplifiers. Why it is a large signal amplifier? Because you are increasing the amplitude of or strength of a input signal very largely. So there is a large signal amplifier. So before that you have to compare the voltage and power amplifiers. Okay, so first chapter and this third chapter, first topic is that what is the need for power amplifier, what is the reason for you are choosing a power amplifier, what is the reason. So because it is transistor amplifier which raises the power level of the signal in a audio frequency range is known as a transistor power amplifier. Okay, that means the power amplifier which is used to raise the power level of the input signal. Okay, so in order to strengthen the input signal, in order to raise the input signal level, power level, so you will use a amplifier network which can call as a power amplifier. And also you can also have the second definition. What is that is the power amplifier may also be defined as the may be defined as the device which converts DC power to AC power and whose action is controlled by the input signal. Okay, very important second definition. What is that? It is the device which can convert DC power to the AC power. Very important. That means you can convert by using a power amplifier, you can convert the DC power into AC power. DC to AC converter you can call as a DC to AC power converter. Okay, so this is the second definition of the power amplifier. The power amplifier which is capable of providing a large amount of power to the load such as loudspeaker or a motor, etc. The power amplifier is also called as a large signal amplifier. I already discussed what is the large signal amplifier. The power amplifier, you can second name is large signal amplifier. So in all essential electronic system we can use large amount of power required to the load. Okay, so and the power amplifier is also used in the last stage in the electronic system. So basically the power amplifier used in the audio amplifier are PA systems. What is a PA system? Public address systems like tape recorders, stereo systems, television receivers, radio receivers, broadcast transmitters. We are using this power amplifier. Okay, is it clear or not? If you see the public address system in the big seminars, halls, or any public addressing seminars, you can see one amplifier which is you can call a PA amplifier, public addressing amplifier, which is there where the last stage of last stage of that amplifier is you can call as a power amplifier. Why? Because a large gathering you should loudly you have to express your speaking skills, speak the speech. So that is the reason not to gather or not to raise the voice to the distant medium. So what will happen? You have to make sure that you have the at the last stage you have to have the more power to raise. So that is the reason we can you have to place a amplifier at the end of the each network or electronic system. You have to place a power amplifier. Okay, is it clear or not? What is the power amplifier? What is the general meaning of power amplifier? It will raise the power level of the input signal in the audio frequency range. That is called a power amplifier. It is a general case or general terminology. You can use the definition. Okay, what is that? Generally, what is that? It will raise the power level of the input signal in the audio frequency range. And the second definition is very important. This is called the technical speaking the definition. Alright, technically you can have concept based definition. What is the concept based definition? Is that you have to convert the DC power to the AC power. It is a device. The power amplifier is a device which will convert DC power to the AC power. You can also call it DC to AC converter. Okay, and power amplifier you can also call as a large signal amplifier. And the most of the all electronic systems you can use this large amount of power to raise at the end of the stage. So that stage you can use a power amplifier. And what is the main usage of this power amplifier in the public addressing systems? Public addressing system, PA systems, what we are like tape recorders, say stereo systems or television receivers or say radio receivers and broadcast transmitters. What will happen, you have to communicate in a large or a distant communication you have to need. So that is the reason you have to place a amplifier at the end of the stage that will raise the power level, so that it will make sure that it will go to the distant. The more communication, the more media we will go. Okay, it will go. So like this we will need of the power amplifier. So what is the second one is the what is the differentiation or distinguish or differences between a voltage and power amplifiers? So what is the major difference between a voltage and a power amplifier? So you can say that voltage amplifier is a small signal amplifier. What you have learned in the first chapter is a voltage amplifier. It is a small signal amplifier. So, and a power amplifier is the large signal amplifier. That means the amplifier is to increase the output power. The amplifier is to use to increase the output power. What is the object of voltage amplifier? Increase the output voltage. Main object is both are same, but what is the difference is the it will strengthen the a small signal. It will output is small. This output is large. The power amplifier output is large, whereas the output of the voltage amplifier is small. That is the concept of both doing is same. Technically speaking, what you are see voltage amplifier and power amplifier doing same, but what is doing in your size of the voltage amplifier is the, you know, it will raise the levels of the somewhat less compared to the power amplifier. The power amplifier raises the power level in the high levels. That is the reason is a large signal amplifier. Voltage is a small signal amplifier. Okay. So and you can see this table, very important. It is, this table is very important. What is that? So beta, what is the beta? What is beta? What is beta?
Power amplification.
Amplification factor or gain, current gain. So beta is less for what? It is less for power amplifier. It is only 20 to 50, very low. Actually, it is less than 50 power amplifier beta. Very high for voltage amplifier. The beta is high for voltage amplifier and beta is less for power amplifier. And RL, what is the load resistance? It is very low, resistance is very high. It is in the order of 10 kilo ohm. Whereas in the case of the load, like loudspeakers or motors, it is have a resistance value very less. It is in the order of only 20 ohms. Okay, ohms, in the order of ohms, 5 ohms, 10 ohms, 20 ohms, that like that only. Okay, because of this, what will happen? You in the power amplifier, you need to have a large amount of power. So that is the reason you have to make a load should be less resistance, so that it will absorb less power. It will absorb less power and it will deliver more and more energy. Whereas in the case of voltage amplifier, you should make the resistance very high, because you are here the voltage amplification is less compared to the power amplifier. Okay. So resistance, it will absorb more. Resistance is more means absorption is also, power absorption also more. So RL is what is RL? It is a load resistance. Load resistance is more in the voltage amplifier, or less in the power amplifier. And the input voltage, what is the input voltage? Input voltage is millivolts, in the order of millivolts. Whereas in the power amplifier is in the order of volts, few volts, 2 to 4 volts. So collector current is low in the voltage amplifier, high in the power amplifier. Already we had learnt what is that is the reason. The collector current more means collector output power or output voltage also more. Okay, the collector current means output current only. So collector current is low in the voltage amplifier, the power amplifier it is high. So power output is low in the voltage amplifier, power amplifier has a high power output. Okay, output impedance is high in the voltage amplifier, output impedance is low in the power amplifier. Why? Because the output resistance or load resistance is low. Okay, and what is the coupling mostly they are using in the voltage amplifier? RC coupling. Okay, resistance capacitive coupling, RC coupling is used in the voltage amplifier, whereas in the power amplifier transformer coupling is used. Okay, you have to run, you have to write down in your running notes these points, very important. They will ask very important, three marks question or 5 marks question. They will directly ask what is the difference between voltage and power amplifiers, distinguish between voltage and power amplifier. Okay, so what is the coupling, type of coupling used in the voltage amplifier? Mostly RC coupling, and the power amplifier will use a transformer coupling. Why transformer coupling is used in the power amplifier? Now to maximum power transfer, now to transfer the more energy to the load, you have to use a transformer coupling. Okay, we have already discussed RC coupling and transformer coupling in the second chapter. So what is the applications? Mostly they will used in as a voltage amplifier, used as a pre-amplifier. That means before the any amplification, you should use pre-amplifier. A power amplifier used in the last stage of any multi-stage amplifier. Okay, so pre-amplifier is voltage amplifier. What is a power amplifier? It is a last stage in a multi-stage amplifier. Pre-amplifier is voltage amplifier. Power amplifier is used as a last stage in a multi-stage amplifier. So what type of configurations mostly used in the voltage amplifier? CE configuration and CB configuration also sometimes uses. But in the case of power amplifier, mostly CE configuration, sometimes you can also use CC configuration. So what is the CC configuration? Buffer amplifier. Okay, impedance matching network. ECC amplifier used as a impedance matching network or a buffer amplifier. Okay, so transistor configurations were both mostly in the voltage amplifier are CECB, whereas in the power amplifier it is CECC. So heat production is low in voltage amplifier and the heat production is very high in the power amplifier. Why? Because what is that? Power amplifier has a beta value, less beta. Less beta means it has a power transistor has a more heat dissipation. More heat dissipation in power amplifier because you are producing a large signal. You are producing a large signal. Okay. Cooling arrangement is not required in voltage amplification, whereas power amplifier you should require cooling. That is the reason you have to use a heat sinks. What is the meaning of heat sink? The name itself it is having heat sinking. That means you have to sink the heat. So that is the device, aluminum mainly, the device which is fabricated on this power transistor, so that will absorb the heat which is generated in the power transistor. Okay, so that is, the heat sinks are provided in the power amplifier. There is no heat sink present in the voltage amplifier. Okay, there are the major differences between a voltage and power amplifier. You have to remember these. You have to learn. You have to practice these characteristics. Okay. So if you see in the block diagram of power amplifier, first stage is voltage amplifier only, and the second stage is the buffer, and output stage is the power amplifier and is connected to the loudspeaker. Okay. So what is the power amplifier? We have a voltage amplification stage, the driver stage and output stage. So in the driver stage we have use a class A transformer. Okay, output stage should be the final stage power directly connected to the loudspeaker. Okay, it will be a output. These are all are something, it is power amplifiers only. In the power amplifier stage, first stage is the voltage amplifier like class A power amplifier. Driver stage is the class B and the output stage is the class C. Okay, like this. There are the different power amplifiers are present in the this overall stage, and this input is given to the at the end of the load. What is the load here? Loudspeaker, or you can also connect a motor. Okay. So what is the another definitions? So the performance, what are the performance measures of the power amplifier? So it is they will also ask in the 3 marks question, what are the different power measures of the power amplifiers? Performance measures of the power amplifiers means there are the three performance measures: collector efficiency, distortion, dissipation capability. So you can also call efficiency, distortion, and dissipation. Okay, there are the three performance measures of power amplifiers. So what is the collector efficiency, or simply you can also call efficiency? Efficiency means output by input. Okay, so what is the output by input? What is the output of the power amplifier? AC or DC? What is the output
AC.
of a power amplifier? Already discussed, DC to AC converter. So what is the output of a power amplifier?
AC, sir.
So maximum AC output power divided by not DC input. This is output. This is input. Change your in your book also, notes and book. What is that? Maximum AC output power to the DC input power. Output power to the input power. Output power is AC. Input power is DC. So that is the reason. What is the efficiency? What is the definition of efficiency? Is overall efficiency or conversion efficiency. Simply, what is efficiency means? It is the maximum AC output power to the DC input power. DC input power, and the efficiency is ranging from 25% to 100%. For example, class A has 25% of efficiency, whereas class D has a 100% efficiency. Okay, like this, it is varying, efficiency is varying. That is the reason you have to place a different power amplifiers in the different electronic circuits. Okay, class A used for the only 25%. That is the reason you are going for a class B. Class B is only 70%. You have to go for a class C. Class C is 90%. Whereas in the class D it is 100% of efficiency. So what is the definition of efficiency? Is maximum AC output power to the DC input power. Change that output to input here in the denominator. Okay, next, distortion. What is the distortion? We already discussed. What is the meaning of noise and distortion? It has some only basic difference. What is the basic difference? Noise is, it is an extra signal. It is added to the original signal. What is the distortion? The distortion is, it is the shape. Shape is different. The output shape is different from the input shape. Whatever the signal you are given to the input side will not get the output side, then you can call as the output is distorted. The output is completely distorted. That means, for example, if you given a sine wave, you are getting a square wave. That is distorted. Correct or not? Okay. So that is the distortion. So distortion is the, what is that? It is the distortion should not present in the any good amplifier. Any good amplifier should not, the distortion should not present in the any good amplifier. But in the power amplifier, distortion will present. In a voltage amplifier, the distortion is less. Whereas in the case of the power amplifier, distortion is there. You can't eliminate completely the distortion in the power amplifier cases. In the voltage amplifier, you can easily eliminate the distortion because the distortion added is very less in the voltage amplifier. Whereas in the case of the power amplifier, the distortion is very high. So completely you can't erase, you can't completely remove the distortion in the power amplifier stages. Okay. So here you can see here the definition. The output is always found to be different from the input, either in its waveform or frequency content. This difference between the output and input of an amplifier is called as a distortion. Okay, already discussed or not. So what is the distortion means? It is a completely different. The output is different from the input. You can call as a distortion. So that means the output is not exactly replica of the input. You can call as a distortion. So in actual practice, it is not possible to construct such an ideal amplifier whose output is exact reproduction of the input signal. Okay, so that is the reason the output is always found to be different from the input either in its waveform or its frequency. If it is there in the amplitude, then it is called amplitude distortion. If it is there in the frequency, you can call it as a frequency distortion. If it is there in the phase, you can call that a phase distortion or harmonic distortion. Okay, so that is something which will there the distortion. So the distortion is completely you can't eliminate in any amplifier stage. Mainly the power amplifiers you can't eliminate completely the distortion. Okay, so distortion is present in power amplifier. So next, what is that? Power dissipation. What is the power dissipation? The name itself it is having the transistors which are used in the amplifier stage which will dissipate heat is known as a power dissipation capability or power rating of the circuit. Okay, it is the ability of the power transistor to dissipate the heat is known as a power dissipation. So you should reduce the power dissipation, correct or not? Now to high amount of output power, you have to more and more output power you have to get that output side. You should reduce the power dissipation because it is the waste energy in the form of heat. It is wasting the energy in the form of heat. That is the reason you have to reduce that heat effect. That heat effect should be reduced, and that should be reduced by using the heat sinks. We already discussed in the differences part. Okay, the heat sinks are used not to reduce the dissipation, power dissipation in the form of heat. Okay, and this is the power. What is the measurements of the performance measurements of the power amplifier, correct or not? So in order to, that is what is the meaning of performance measurements means, in order to identify, in order to compare two power amplifiers, which one is best. So that is should be compared by using these parameters: efficiency, distortion, and dissipation. Efficiency for a good amplifier, power amplifier, efficiency should be very high. Distortion should be as minimum as possible, as well as the power dissipation should be also as minimum as possible. Whereas the efficiency as maximum as possible. You should have the maximum efficiency but minimum distortion as well as a power dissipation for a good power amplifier. Okay, so these are the some elements you have to perform measurements in the power amplifiers. Okay, so the next topic, what is that is classification of power amplifiers based on the conduction angles. You can call it the conduction angles of input signals, okay, or output signals. So it is the conduction angles of the output signals. So depending on the conduction angles of the output signals, you can classify the power amplifiers. What are they? Class A, class B, class AB, and class C, as well as class D also. Okay, you can also add E. What is the E? Class D power amplifier. Okay, so class A, class B, class AB, class C, and class D amplifiers. They are the classification of the power amplifier based on conduction angle of output signals. Okay, then what is the class A power amplifier? What is the definition of class A power amplifier? Means the collector current or the output current flows at all times during the full cycle of the input signal. The power amplifier is known as a class A power amplifier. Is it clear? That means the conduction angle is complete or 360 degrees. Then you can call as a class A power amplifier. The output signal will conduct fully. The output signal or collector current signal which will flows completely or fully, then you can call as a, what is that? Class A power amplifier. That means, for example, your input signal is sinusoidal signal you are given, output also sinusoidal signal, and it is completely you should conduct. That means the for input signal 360 degrees it is varying, means output signal also you should vary 360 degrees. Then you can call as a class A power amplifier. What is class B power amplifier? Means the collector current flows only during the positive off cycle or negative off cycle. That means only 180 degrees. Okay, class B power amplifier will conduct only for 180 degrees of input signal. That means output you are getting only conducting only either positive half cycle or negative half cycle, not full cycle. It will not conducting full cycle. It will conduct completely, not completely. It is off cycle only. It is conducting. The output signal is only off. Okay. For example, your input signal is sinusoidal. Complete signal you are giving means output here. Output signal not you are getting fully. It is only half of the signal you are getting. That means it is current flow is 180 degrees. Class B power amplifier has a 180 degrees conduction angle. Okay. Is it clear? That is the reason a classification of power amplifier based on the conduction angle, output conduction angle, or output power signal or collector current. Okay. Next, what is the class AB? You can see that you can it is the in between the class A and class B. That means what is that? It is the collector current flows more than half cycle and but less than the full cycle. That means greater than 180 but less than 360 degrees. That means the output signal is conducting only greater than 180 degrees but less than 360 degrees. That means 180 plus or 360 minus. 180 plus theta or 360 minus theta. That only angle it will be. For example, 270 degrees. 270 degrees is in between a 180 and 360. That means 270 degrees only it will be conducting. 1.5 cycle. You can say that it is 1.5 cycle. Okay. Not full cycle. Okay. So 1 plus half only. Not full. Full is 2. Is 1.5. Only it is 1.5 cycle only it will be conduction. AB. Class AB power amplifier. That means, for example, you are giving input signal is 360 degrees. Only 1.5 cycle only it will conducting, not full cycle it is conducting. Okay, it is the class AB power amplifier. What is the class C amplifier? You can imagine. What is the class C? The collector current flows less than half cycle. That means less than 180 degrees. Less than 180 degrees if it is flowing, then it is called the class C power amplifier. Okay, less than half cycle. Either it is positive half cycle or negative half cycle, but it is less than half cycle it is conducting. That means 180 less than 180 degrees. Okay, so you should write down in your notes. Class A means full cycle 360 degrees. Class B 180 degrees. Class AB greater than 180, less than 360. Class C less than 180. Class D it is less than 90 degrees. Less than 90 degrees. Okay, so less than 90 degrees you can call it as a class D power amplifier. So that means you can see the if input is full cycle, but output is not completely full cycle. In the case of a class B, class AB, class C, and class D, that means very high distortion. Correct or not? You are getting a full cycle in the input side, but output side you are not getting a full cycle. That means output signal is completely different shape from its input shape. So that is the reason it is distorted. The output is distorted. That is the reason I already told that power amplifiers completely it is having some distortion. You can't eliminate that distortion. But even if it has the distortion, it has the efficiency, very high efficiency power amplifiers compared to the voltage amplifiers. Okay, so distortion is present but the efficiency also very high. Okay, so class C amplifier is less than half cycle, either it is a positive half cycle or negative half cycle. Okay, so this is the classification based on the conduction angle of a amplifiers and the conduction angle of a collector current or output current. So already discussed that what is the conversion efficiency. What is the conversion efficiency? AC, maximum AC power output divided to the DC power input. So same thing, efficiency is also called as a conversion efficiency of an amplifier. Efficiency of an amplifier represents the amount of AC power delivered or transferred to the load from the DC source. Is it clear? So here you have to remember that one thing. What is that means? What is input you are giving actually? Input is AC or DC? All of you.
DC, sir. DC, sir.
Actually, what is that? DC is the power supply, but AC is the input signal. Input signal is AC only. Output signal is also AC, but DC is the your power source VCC. VCC is the DC. Here, power amplifier will tells us that what is the conversion of the DC voltage to the AC voltage. That means what is the VCC is converting, how much energy of VCC is ECC of the DC is converted to AC. Not the what is the input you are giving in the input side of the power amplifier you are estimating. You are estimating that what is the DC voltage you are giving in the VCC, it is how much is converting, into the AC. That is the reason I already told it is a DC to AC converter, or what is that? It is a simply you can also call as a something like a generator AC. What is the oscillator type? Because what is the VCC is given, how much energy is given, how much energy of VCC is given, that is DC is converted into how much energy of at the output side AC. So you are, that is the reason it is a conversion efficiency. It is how much DC is converted into AC, that is E conversion efficiency. You can call it as a conversion efficiency. Okay. So conversion efficiency, the formula is that general formula, you remember this. So there is no need of this derivation for this here, but you just remember what is the efficiency of a power amplifier means here. So percentage of eta. So efficiency is it is denoted by eta, the symbol eta. So percentage of eta is PAC by PDC into 100. So what is the PAC is V max minus V min into I max minus I minimum divided by 8 into VCC into ICQ into 100. Remember this formula. Okay. Remember this. This will help you in the calculation purpose, the analyzing the different amplifier stages, class A, class B, class C, like this. Okay. So remember this. The percentage of eta, which is PAC by PDC, power output, AC power output, maximum AC power output to the DC power input, into percentage means into 100. Okay. So percentage of eta is equal to, so that is if you derive this whole thing, you will get a V max minus V minimum into I max minus I minimum. V max means maximum voltage, V minimum means minimum voltage, into current I max minus I minimum divided by 8 into VCC into ICQ. VCC is the supply voltage. Okay, this is a DC. ICQ means it is a supply current. ICQ is a quiescent current, also supply current or DC current. ICQ, Q for quiescent current. Okay, ICQ and collector current, quiescent into 100. Okay, this is the formula for conversion efficiency for any power amplifier. It may be a class A, it may be class B or C or class AB or class D. Okay, so anything, the formula is common. This is a generalized formula for the power amplifiers. Okay, so next, if you see in the here, you can see this tabular form very important, because you can easily have the overall conclusion for this AB power amplifiers. Okay, so see here what is the characteristics in the this column, and what is the performance in the this columns. So class A is a conduction angle. For a class A conduction angle, what is the conduction angle? A 360 degrees, B 180, C less than 180, AB 180 to 360. Is it clear? So what is the position of Q point? Q point means it is the operating point. So in the class A, it is center of the load line. So in the class B, it is on x-axis. The class C, it is below x-axis. Class AB, it is in between a class A, class B. That means above x-axis and below the center of the load line. Okay. So and efficiency, what is the efficiency of the class A power amplifier? This is important, efficiency, just remember. Okay, 25 to 50% only, poor. Class A has less efficiency. So in the class B, it is somewhat better. So 78.5%. In the class C, very high. It is about 90%. You will write in the brackets 90%. It is class AB, it is higher than A but less than the class B. It is 50 to 78.5%. It is in between the 50% to the 78.5%. So what is the distortion? Distortion is present in all power amplifiers except class A power amplifier. Correct or not? So no distortion is present in the class A power amplifier. Class B, it is more than the class A power amplifier. It is highest in class C because highest efficiency but lowest distortion. It is highest efficiency as well as highest distortion. Okay. So in the class AB also some distortion is present, but it is less than the class C power amplifier. Okay. Is it clear?
Yes, sir.
Tabular
Yes,
form,
sir.
this tabular form very important. You have to write down in your running notes. So I will conclude here the class. So we will discuss in the next class what are the definition of a distortion, different distortion, amplitude distortion, phase distortion, frequency distortion, crossover distortion, outband distortion, in-band distortion, like this. Okay. So I will wind up here. Tomorrow class I will discuss these types. Okay, distortion types of the distortion. Is it clear, all of you? What is power amplifier?
Yes, sir.
Cheppandi, what is the power amplifier?
Raises the input signal.
Signal in audio frequency range.
It converts DC into AC, sir.
Very good. So normal or general definition is that it will raise the power level in the audio range. You can call it as the power amplifier. It is a normal definition. What is the technical definition or a specific definition is that it will convert DC to AC. How much DC, how much VCC it is given to the circuit, that will how much that DC is utilized by the circuit, and it will convert into AC. That is DC to AC converter. Power amplifier is simply a DC to AC converter. That is the reason it is also having the properties of oscillator. Correct or not? Oscillator also doing same thing. It will converting DC to AC. Okay. So power amplifier is also having the properties of the oscillator because it is converting a DC to AC. And what is the difference, major difference between the voltage amplifier and power amplifier? Cheppali.
Voltage.
It amplifies the small
Signal amplifier.
So in the case of the voltage amplifier, the signal amplification is less, whereas voltage power amplifiers, the signal amplification is large. So that is the reason voltage amplifier is a small signal amplifier, power amplifier is a large signal amplifier. Which one has the more distortion, power amplifier or voltage amplifier? Distortion, which one has more? Distortion ఎందులో ఎక్కువ ఉంటుంది?
Power amplifier.
పవర్ యాంప్లిఫైర్ హాస్ మోర్ డిస్టార్షన్. చూసింది కదా ఇప్పుడు ఆల్రెడీ నేను డిస్కస్ చేసిన ఏమని చెప్పా, ఇన్పుట్ సిగ్నల్ ఫుల్ సైకిల్ ఇస్తే అవుట్పుట్ సిగ్నల్ ఫుల్ సైకిల్ రావట్లేదు. ఓన్లీ క్లాస్ ఏ పవర్ యాంప్లిఫైర్ లో ఫుల్ సైకిల్ వస్తుంది. మిగతా పవర్ యాంప్లిఫైర్స్ లో ఫుల్ సైకిల్ వస్తుందా? వస్తలేదు. 180 degrees వస్తుంది, ఒకసారి 180 లెస్ దెన్ 180 వస్తుంది, ఒకసారి 180 to 360 మధ్యలో వస్తుంది. ఓకే, ఒకసారి లెస్ దెన్ 90 వస్తుంది. ఓకే, so that means the shape is different, the output shape is different from the input shape. That is the reason it is a distorted, the output is distorted. So distortion is more in power amplifiers. Okay, so do in the homework, what is your homework today is, first you have to, what is the definition of power amplifier and what are the different types of power amplifiers. Okay, and the comparison between the class A, class B and class AB and class C amplifiers. Okay, this is your homework today. So First you have to do that homework, okay, today. So I will wind up this class, okay.
Okay, sir.
Right.